Hello viewers, in today's class we are going to discuss an important method in indefinite integration which is known as substitution method, right? And in this lecture we are going to discuss four problems which can be solved using the method of substitution, right? And this lecture is going to be very useful, and it is especially dedicated to the beginners, right? So let us start. Now viewers, whenever we do indefinite integration, there are different methods of doing indefinite integration, right? And substitution method is the first important method while dealing with indefinite integrals, right? So let us take these problems one by one, and by solving these problems we can also get acquainted with the method of substitution. So let us first take this problem. So let us call this integral as I, right? And we have the integral dx over e raised to x plus e raised to minus x, right? Now see, if we compare this integral with this one, that is f of x dx, then our integrand is f of x, right? And f of x is equal to 1 over e raised to x plus e raised to minus x, right? Now let us first simplify this expression, right? So we can write this expression as e raised to x plus 1 over e raised to x, because this is e raised to minus x, right? And here we can take the LCM. So we have 1 over e raised to x times e raised to x is e raised to 2x plus 1 divided by e raised to x. Now we can take e raised to x to the numerator. So we have e raised to x over e raised to 2x plus 1, right? Now let us visualize this function like this, that is e raised to x, and then we can write e raised to x square plus 1, right? So now our integrand f of x can be written like this, right? So now I can be written as integral, and here we have e raised to x divided by e raised to x square plus 1 dx, right? Now see, if we closely observe this integrand, then we can see that the derivative of e raised to x, it appears in the numerator, right? See, the derivative of e raised to x is e raised to x itself. So whenever we apply or we do integration by substitution method, we should have a strong observation, right, regarding the derivatives. So here we see that the derivative of e raised to x is appearing in the numerator, right? So here we can now make an important substitution by introducing a new variable, say t, right? So we'll substitute t is equal to e raised to x, right? So the derivative dt over dx is simply e raised to x, and now taking dx to this side, we have dt is equal to e raised to x and dx, right? Now see, here in the numerator we have e raised to x dx. So now this integral I can be written in terms of this new variable t, right? So the prime objective of substitution method is to simplify the given integrand and introducing a new parameter or new variable t, and reducing the integrand into a known integral, right? So now see, here we have e raised to x dx. So now e raised to x dx is dt. So we can now write dt in place of e raised to x dx, and e raised to x is already assumed as t. So this is now t square plus 1, right? So now we can see that this integral is now transformed to this integral. So this integral was in terms of x, and this is in terms of t, right? And now see, this integral is a standard integral, because we know that the integral of 1 over x square plus 1 is tan inverse of x, right? So the direct result for 1 over x square plus 1 is tan inverse x. So here we can now write tan inverse of uh, t, because here the variable is t, and will not forget to write the constant of integration, right? So c is the constant of integration. Now this is the integral of this function, but here we have the variable t. So again, while writing the final answer, we'll express the final result in terms of x. So replacing again t by e raised to x, we have here tan inverse e raised to x plus c, right? So this is the integral, or the indefinite integral of this function, right? Now let us take the second problem. So let us call this integral as I. So we have integral, and here we have a square root of e raised to x minus 1 dx, right? Now see here, if we observe this integrand, which is a square root of e raised to x minus 1. So f of x is e raised to, here we can write integral fx dx. So fx is square root of e raised to x minus 1, right? Now see here, we have a square root sign. So what we will do, first our aim is to get rid of this square root sign, right? So we'll introduce uh, a variable t such that t square is equal to e raised to x minus 1, right? So viewers, while applying the substitution method, sometimes we have to make some important guesswork. So here what we have done, we have assumed this quantity which is inside the square root sign as t square, so that we can get rid of this square root sign, right? So now t square is e raised to x minus 1. So now let us differentiate both sides with respect to x. It means we should write d by dx of t square, and here we have d by dx of e raised to x minus 1, right? So now the derivative of t square with respect to x. So first we'll find the derivative of t square with respect to t. So we have 2t, and then by chain rule we have dt over dx, right? Now the derivative of e raised to x with respect to x is e raised to x, and the derivative of 1 being a constant is 0. So now we have this expression, right? And let us have a close look at this expression. So here we have 2t dt by dx and e raised to x, right? So here we have this quantity e raised to x, which can be written in terms of t by this expression. So e raised to x is equal to t square plus 1. So taking this negative sign to this side, we have t square plus 1. So now e raised to x is t square plus 1. So now here we can write 2t dt is equal to t square plus 1, and here we have dx, right? So dx can now be written as 2t over t square plus 1 and dt. So the value of dx can be replaced by this expression, which is entirely in terms of t. So now this integral I can be written as, here we have square root of e raised to x minus 1. So t square is e raised to x minus 1. So it means t is the square root of e raised to x minus 1. So we have t, and dx is 2t over t square plus 1 dt, right? So this is 2t square, 2t times t, 2t square plus 1, and dt. So now here what we will do, we'll take these two outside the integral sign, and we are having t square over t square plus 1 dt, right? Now to move further, here what we will do, we'll add 1 and we'll subtract 1, right? And we'll split the integral at this point. So we have 2, and we can first write integral t square plus 1 over t square plus 1 dt, and then we'll write 1 over t square plus 1. Here we have 1, and t square plus 1 and dt, and here we can write t square plus 1, t square plus 1 get cancelled, so we are left with simply dt. And here the integral of 1 over t square plus 1 is simply tan inverse of t, right, which we have just discussed while solving this problem number 1, right? And here we have the constant of integration as c. So now the integral of dt is simply t. So we have here t minus tan inverse of t plus c, and now replacing t by square root of e raised to x minus 1. So the integral I is written as square root of e raised to x minus 1 minus tan inverse of square root of e raised to x minus 1, and plus c, where c is the constant of integration. So now let us consider the third problem. So here we have the integral e raised to 2x divided by 3 times e raised to 2x minus 4, right? Now again, here we'll closely observe our integrand, right? So here we have integral f of x dx, and f of x is e raised to 2x divided by 3 times e raised to 2x minus 4. Now here if we see the derivative of e raised to 2x, it exists in the numerator, right? So we know that the derivative of e raised to 2x is 2 times e raised to 2x, right? So here this factor, that is 2 e raised to 2x, it appears in the numerator. So what we will do, we'll take this entire term as t, right? So we'll take t is equal to 3 times e raised to 2x minus 4. Now let us differentiate both sides with respect to x. So we have d by dx, and here we have 3 e raised to 2x minus 4, and c, 3 is a constant. The derivative of e raised to 2x is 2 e raised to 2x, and then the derivative of 4 with respect to x is 0, being a constant, right? So this is 6 times e raised to 2x. So dt over dx is 6 e raised to 2x, right? Now taking dx to this side, so we have dt over 6 is equal to e raised to 2x dx, right? So viewers, now we have a term containing t, that is dt over 6 for e raised to 2x times dx. So now this integral I can be written as integral for e raised to 2x dx. We can write dt over 6, right? dt over 6. And for 3 e raised to 2x minus 4, we can write simply t, right? And now we can take 1 over 6 outside the integral, and we have dt over t, right? Now we see that this is a known integral, right? we know that the integral dx over x is simply a log of x, right? So this is the natural log. So here we have 1 over 6 and the log of t, and c is the constant of integration. Now to get the final answer, let us replace t by 3 e raised to 2x minus 4. So I can now be written as 1 over 6 log of 3 e raised to 2x minus 4 plus c, right? So this is the final answer for this integral. Now viewers, let us take the fourth problem, and here we have integral e raised to 1 minus 4x and dx, right? Now here we see that we have the exponent as 1 minus 4x, that is the exponent is a function of x itself, right? So what we will do, here we can take the substitution as t is equal to 1 minus 4x, right? So here 1 minus 4x is a linear function. So let us differentiate both sides with respect to x. So we have dt over dx, and here the derivative is 0, 1 being a constant, and here the derivative of x is 1. So this is minus 4 simply, right? So dt over minus 4 is equal to dx, because here dt over dx is equal to minus 4. So now for this dx, we have dt over minus 4, right? So now I can be written as integral e raised to t, because 1 minus 4x is t, and for dx we have dt over minus 4, right? Now 1 over minus 4 being a constant, we can take it outside the integral. We have integral e raised to t dt, and now we can see that this is a known integral, right? So the integral of the exponential function is the function itself. So integral e raised to x dx is simply e raised to x. So here we have minus 1 over 4 and e raised to t, and c is the constant of integration, right? So always remember that whenever we find the indefinite integral, never forget to add the constant of integration in the final answer, right? So now we have minus 1 over 4, and here we have e raised to t, and t is 1 minus 4x, and here c is the integration of constant of integration, right? So this is the final result for this integral.